we need to find a quadratic equation that fits this set of data points. So basically they're giving us three different points. A quadratic function is a function that's of the form f of x equals ax squared plus bx plus c. So what we're going to do is we're going to put in this for x and this for y. We know f of x is the same thing as y. So we're going to get 107 equals a times negative 5 squared plus b times negative 5 plus c. Then we need to do the same thing for the next point. So this one's our x and y. And so we put in 5 for the y, and that's going to equal a times 1 squared plus b times 1 plus c. And then we're going to do that one more time for this x and y. So we've got 67 equals a times 3 squared plus b times 3 plus c. Now what we have here is a system of three equations and three unknowns. So this is a throwback to when we learned systems of equations. This will actually be an excellent review for the final. There's usually always a 3x3 system on the final. So we're going to rewrite these kind of more like we're used to seeing. So it's going to be 25a minus 5b plus c equals 107. And then the next one is going to be a plus b plus c equals 5. And the last one's going to be 9a plus 3b plus c equals 67. Now with the 3x3 system, it's a, b, and c instead of x, y, z, but it's the very same things. We want to eliminate one of the variables. Well, if you look at these c's here, these are by far going to be the easiest to eliminate because they're just plain old c's. They don't have these other coefficients. So first we're going to use these first two equations. I'm going to go through the second equation with a negative 1. And what that's going to do is give me 25a minus 5b plus c equals 107, and I'm going to have negative a minus b minus c equal minus 5. So I went through that one with a negative 1. When I add these together, I get 24a minus 6b. The c's are eliminated. That's what I was trying to do, equals 102. So I have an equation with just two variables. Now I'm going to do that again, but this time I'm going to use the middle one with the bottom one. I'm going to list the bottom one first. 9a plus 3b plus c equals 67, and go through the middle one with the negative. Negative a minus b minus c equal negative 5. Adding those up, I get 8a plus 2b, these are eliminated, equals 62. Now I have two equations and two variables, but actually they will both reduce, and if you'll reduce them you'll have smaller numbers to work with and it'll make it easier. I can see there's a common 6 in everything here, so I'm going to get rid of that, and there's a common 2 everything here, so I'm going to get rid of that, and those will just make them easier to deal with. So this is going to be 4a minus b equals 17. And this one's going to be 4a plus b equals 31. Well, now if I just line those up, the b's are going to be eliminated. So let me write this one underneath this one. 4a plus b equals 31. And if I add those up, the b's are gone, and I get 8a equals 48. Divide both sides by 8, and a equals 6. Now I'm going to substitute that in so that I can find b, and I'll go ahead and just put it in this one. So I have 4 times 6 plus b equals 31. So this is 24, so I can subtract it from both sides, and it looks like b equals 7. Now I need to put both a and b in an equation that also involves c, and this is the easiest one up here, this middle one. So I'm going to do that, and so I'm trying to figure out where to put it. I'm actually going to write it down the side. So my a is 6 plus my b, which is 7, plus c equals 5. So I can combine those. 13 plus c equals 5, and c equals negative 8. Sideways. Okay, so now we have our A, B, and C. So our final answer is going to be going back to this quadratic function and putting those in. So A was 6, so 6x squared, plus B was 7x, and C was negative 8. So there is my quadratic function that contains these points, or these fits those points. If I plug those points in, they would all make that true. Now this one is like number 10, and if you look at number 11, it looks like this, so it looks like a different problem, but it's really the same problem. They just don't give you these as ordered pairs, they give them to you in a table. But your first ordered pair is 60 and 1210. Your second ordered pair is 80 and 1160, and your third ordered pair is 100 and 1160. And then from there, it's the very same process I just did in the last example.